Keras LSTM predicted time series squashed and shifted. I'm trying to get some hands-on experience with Keras during the holidays, and I thought I'd start out with the textbook example of time series prediction on stock data. So what I'm trying to do is, given the last 48 hours worth of average price changes, percent since previous, predict what the average price change of the coming hour is. However, when verifying against the test set, or even the training set, the amplitude of the predicted series is way off, and sometimes is shifted to be either always positive or always negative, i.e., shifted away from the 0% change, which I think would be correct for this kind of thing. I came up with the following minimal example to show the issue. As you can see, I create training and testing sequences by selecting the last 48 hours, and the next step into a tuple, and then advancing 1 hour, repeating the procedure. The model is a very simple one LSTM and one dense layer. I would have expected the plot of individual predicted points to overlap pretty nicely the plot of training sequences. After all, this is the same set they were trained on, and sort of match for the test sequences. However, I get the following result on training data. Orange, true data. Blue, predicted data. Any idea what might be going on? Did I misunderstand something? Update. To better show what I mean by shifted and squashed, I also plotted the predicted values by shifting it back to match the real data and multiplied to match the amplitude. As you can see, the prediction nicely fits the real data, it's just squashed and offset somehow, and I can't figure out why.
Since the dimensionality of your data is 1, an LSTM with 25 units seems rather complex for such a low-dimensional dataset. Here's a list of things that I would try. Decreasing the LSTM dimension. Adding some form of regularization to combat overfitting. For example, dropout might be a good choice. Training for more epochs or changing the learning rate. The model might need more epochs or bigger updates to find the appropriate parameters. Update. Let me summarize what we discussed in the comments section. Just for clarification, the first plot doesn't show the predicted series for a validation set, but for the training set. Therefore, my first overfitting interpretation might be inaccurate. I think an appropriate question to ask would be, is it actually possible to predict the future price change from such a low-dimensional dataset? Machine learning algorithms aren't magical, they'll find patterns in the data only if they exist. If the past price change alone is indeed not very informative of the future price change, then your model will learn to predict the mean of the price changes, probably something around 0, since that's the value that produces the lowest loss in absence of informative features. The predictions might appear to be slightly shifted because the price change at time step t+1 is slightly correlated with the price change at time step t, but still, predicting something close to 0 is the safest choice. That is indeed the only pattern that I, as an inexpert, would be able to observe, i.e. that the value at time step t+1 is sometimes similar to the one at time step t. If values at time steps t and t+1 happen to be more correlated in general, then I presume that the model would be more confident about this correlation and the amplitude of the prediction would be bigger.
Increase the number of epochs. You can use early stopping to avoid overfitting. How's your data scaled? Time series are very sensitive to outliers in the data. Try min-max 0.1, 0.9, for example, and then robust scalar is also a good choice. I'm not sure that LSTM sec_len is really necessary until you have a lot of data. Why not to try the smaller dimension? Try all of this and try to overfit. This should be around 0 on a real dataset. Then apply regularizations. Update. Let me explain you why did you get by. A good fit. Okay, let me consider LSTM layer as black box and forget about it. It returns us 25 values, that's all. This value goes forward to the dense layer, where we apply to the vector of 25 values function. Here W and B, vectors that are defined by nn, and in the beginning are usually near 0. X, your values after LSTM layer, and Y, target, single value. While you have just one epoch, W and B are not fitted at all to your data, they are around 0 actually. But what if you apply? To your predicted value? You, some way, apply to the target variable W and B. Now W and B are single values, not vectors, and they are applied to single value. But they do almost the same work as dense layer. So, increase the number of epochs to get better fitting. Update 2. By the way, I see some outliers in the data. You can try also to use Mayer's loss/accuracy metrics.
I had the same problem this week and I found the solution. The only thing that worked for me was using window normalization method as described here. This URL. Check the part about SB 500 forecasting. Have a good day, smile.
Because I'm at this point as well, batch_size increase helps completely. The simple RNN fixes the LSTM problems with ReLU. ELU's activation, learning rate has to be increased from default, and try and configure some smote RNN Sultian for more past data, or change the time period between rows to acquire more data for the model to find patterns with. Seems to work for me. ATM, still trying to push above 80% accuracy. Accuracy equals mean_abicule_error, test.mean, 100.
If you want to see more classical subscribe.